Happy Saturdays. This is Dr. Callahan with Week 14 Monday. How are you guys doing? I hope you had a wonderful weekend. So go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, let's go ahead and get started with today's stuff. So this is your guided notes for today. So if you don't have this with you, you are welcome to just kind of copy it on a separate piece of paper, which is completely fine. Let's go ahead and take a look at the first part. Today, I'm going to talk about a new topic, which is similar to Euler's path and circuits, but it is going to involve adjacency matrix, which is the next step of this. So as I'm looking at this part right here, there are several ways to describe a graph. Now, if you were to describe the graph with a diagram, that diagram will look like that. And you can ask yourself, well, gee, is this a path? Is this a circuit? Is it neither? Now, if you're describing it with a list of vertices or edges, you can list the vertices. So you have A, B, C, D, E. And you can also list the edges, such as AC, CB, BD, BE, CE, and then CD. So different ways of listing it. Now, the new one is with an adjacency matrix, and how the adjacency matrix works is that you're essentially just looking at the keyword adjacency, which means next to, and seeing the connections between each point. So with A and A, there's no connection because it's the same dot, so it's a 0. With AB, so from A to B, there's no connection because there's no lines here, so it's 0. A to C, there is one line, so it's a 1. AD, there's no connection, so it's 0. AE, it's 0. Now let's go ahead and take a look at B, okay? With BA, there's no connection, so it's 0. BB is itself, so 0. BC, guess what? There's one connection. BD, there's one connection. BE, there's one connection. So 1, 1, and 1. Now let's take a look at C. CA, there's one connection. CC or CB, there's one connection. CC, there's no connection because it's itself. And then CD, there is one connection right there. And then CE, there's one connection. Then let's take a look at D. No connection with DA. There is a connection with DB. There's also a connection with DC. There is no connection with DE, and there's no connection with DD. Last one that you have here is E. With E, there's no connection with EA. There is a connection with the EB. There's a connection with EC. There's one connection, or actually there's no connection with ED. So now that I've done this, I want you guys to go ahead and try it with this one here. So you're going to create a matrix. There's 1, 2, 3, 4, 5. So we're going to go ahead and put A, B, C, D, E, A, B, C, D, E. And you can either put a 1 in the corresponding position if the vertex is adjacent to another vertex, or you could put a 0 if the vertex is not adjacent. So let's take a look at this. AA0, BB0, CC0, DD0, EE0. So let's just do that first. AB, there's 1, 0, AD, there's 1, AE, there's 1. BA, there's 1, BC, there's 1, BD, there's 1, BE is 0. CA is 0, CB is 1, CD is 1, and then CE is 0. DA is 1, DB is 1, DC is 1, DE is 1. Then EA is 1, EB is 0, EC is 0, ED is 1, because there's a connection. So that is your adjacency matrix. Now that I've done this one, I want you guys to kind of practice on your own with this one. So here you have M N O P. Let's say M N O P R S. Or actually, yeah, there is a M N 3, 4, 5, 6, 7. Oh, you know what? I need to have, sorry, one more line here. So just draw one more like that because I'm missing one. Sorry. There we go. And then RS. And then do the same thing, MNOPRS. So pause the video and go ahead and fill this part out. All right, let's go ahead and take a look at the answer. It's a good form to put your variables in alphabetical order, so that way it's easier to track, and this is what it should look like. All right, let's try next one. Next one here you have A, B, C, D, E, A, B, C, D, E. Now you know it's going to be a 0, 0, 0, 0, 0, and go ahead and fill out the rest of the chart. And let's go ahead and take a look at the answer. So this is what your answer should look like. Oh, and you know what? I made a little typo because I put 0 here, but really A is a connection. It's a non-zero number on the main diagonal, indicate that there's a loop, so that should be a 1. DD should also be a 1, so I'm going to change that. And that's about it. Let's see. Yep, that's about it. All right. Now, what if our vertex looks, instead of a diagram, you have the vertex given to you and also the edges. So looking at this, we'll start off with E, F, G, J, K, M, E, F, G, J, K, M. So let's think about the connections here. So first things first, EE is 0, FF is 0, GG, JJ, KK, MM, all zeros. But then you look at EF, well, there is one, so there's a connection. EG, there's a connection right there. EJ, no connection. EK, no connection. And then EM, no connection. Next, we'll take a look at FE. So FE, yes, there's a connection, or EF is the same thing. Then FG, there's one connection right there. FJ, 0, 0, 0. Okay, then let's take a look at G. GE, there's a connection right here. GF, there's a connection right there. GJ, 0, 0, 0. Now we're going to go on to J. So JE, nothing. JF, nothing. JG, nothing. JK, there's one. JM, there's another one. Then let's take a look at K. So KE, nothing. KF, nothing. KG, nothing. KJ, actually there is one. KJ right there. So there's one right there. Okay, then KM, it's another one. All right, you guys, ME is 0, MF is 0, MG is 0, MJ, there's one right there, and MK, there's one right there. And this is how you fill out the adjacency matrix using the vertice list and edges list. Now I want you guys to try this one on your own. All right, take a look at your answer then. All right, so let's take a look at example 2. It says draw the adjacent matrix. So looking at this one here, I have my vertex A, B, C, D, and then A, B, C, D. So looking at this, AA is a 0. There's no loops. I noticed that. 0, 0, 0. Then AB, there is a line, so there's 1. AC, 0, AD, 0. BA, there's a 1. BC, there's a 1. BD, there is a 1. CA is a 0. CB is a 1. And then CD is a 1. DA is 0. DB is a 1. DC is a 1. All right, so I'm going to have you guys go ahead and pause the video and take a look at the following. Be careful with the loops right here, okay? And then take a look at your answer. Do be careful that with the EE, because it's a loop, it's also considered to be a 1, not a 0. Okay, so looking at this, here are more terminologies. Simple graph means no multiple edges. Multigraph means many edges and no loop. Pseudograph means loops, possibly at multiple edges also. And so main loops shows up on the main diagonal. So let's take a look at example 3. Which type of graph is represented by the following adjacency matrix? So I want you to assign these vocabularies to one of these. So match them, please. Pause the video. All right, so the first one is a loop. So because of the loop, there are no multiple edges. Because we look at this one, if this is B, that's the same thing as B. Okay, for B, because this is a loop and no multiple edges, it is called a pseudogram. So that is your answer for this one. All right, so for B, as you look over here, notice the diagonal is all 0. And so because the diagonal, so it's saying loops showing on the diagonal, this one is going to be no loops, okay? Because everything here, the diagonals has 0, which means AA does not have a loop, BB doesn't have a loop, CC doesn't have a loop, so no loop. This one is called a simple graph. Okay, so then for C, there's no loop because AA is not a loop, BB is not a loop, so no loops. But then also if you take a look where there's like a number 2 right here, what that means is that there are multiple edges. So this one is going to be a pseudograph or a multigraph, excuse me, which we have not talked about yet. But a multigraph means the number of connection edge is more than 1, so it's greater than 1. So that is something different, and we'll talk about that next time. All right, you guys, that's basically it. And so I'm going to have you guys go ahead and practice a little bit on a quizzes. So let's go ahead and take a look at this. So I'm going to go ahead and reshare my computer. I'm going to sign up for a homework for you guys. And you guys have until 3 p.m. today to go ahead and complete it. So make sure you guys go to 6531-2434 and type that in to joinmyquiz.com. It is going to be a graph introduction, and there are 10 questions. Okay, so then after that, what I want you guys to do is to watch this video right here. It is 14 minutes, and I want you to answer the following questions when it comes to it, such as what is an adjacency matrix, how does it relate to Euler circuits and path, and where can you apply this to real life? Okay, so you can watch a video on your own. You could do this one of three ways. Number one that you can do is just go ahead and type in graph representation part 02 adjacency matrix on YouTube, and you should find this video. It's 14 minutes. Next thing you could do is you can either type this in, which can be a little bit long because there's a lot of words in there and letters, or you can use a QR code to go ahead and snap it with your phone if you can, if you have this on a laptop, you have your phone available, and then watch the video and answer the following questions. All right, you guys, I hope you have a wonderful week. And as always, stay safe and healthy, and I'll see you guys next time. Take care.